be going over the 5B-2, so key features of radical functions. It's been probably a while since we did this, so this is supposed to be prior knowledge, meaning like we've already done it before, but it's been since I don't even know when we did rational equations. I don't even know, it's been a while. So let's just practice together the prior knowledge. So I'm going to use two different colors, which is why I asked you to have two different colored highlighters. I'm going to use blue for the domain. You can just pick a color. If you have yellow, use yellow. If you have orange, use orange. So the domain are which values? The x's or the y's? The x's. So I'm going to put an x for my domain. You're on 5B2. You're supposed to be 5B2.
What is yours again? I still can't see it.
Oh my god, those.
Put it right in there.
Okay. I'm like, do you need to switch with one of these people over here? Okay. Something too I forgot. On your papers, it says inequality. Cross out the inequalities. Bianca, is that my bundt cake?
This is because nothing but thankful for you.
Yeah, I was asking Andrew this morning. I was like, hey, when am I getting my bundt cake? Thank you. Huh?
I got a cup of dirt.
Yeah, I did. Like, I got a little succulent plant too. This one's cute. Like, I like the little box. It's cute. She was grateful. All right, so the domain again is the x values. So if you remember, in the rational equations, we have these dashed lines. Don't highlight them. I'm just doing them so it stands out in red. But remember that those dashed lines are imaginary lines. They're like border lines. You can't cross or touch the dashed line. So then we have to break up the domain and the range at that value, okay? So if I look at the x-axis from the left, I'm going to go up until the asymptote. And I'm going to put an open circle at the 3. And then I'm going to continue highlighting all the way to the right side, okay? You can do the blue highlight, yes. So that is my domain. It starts at the left, and then you cannot have the value of 3, so I would put an open circle, and then it goes on forever to the right side. Okay. So that arrow going forever to the left is representing which infinity? Going forever to the left is going forever to negative infinity. Okay? And then it stops at the 3 right here because of the asymptote. And then it's going to go forever to the right side to which infinity? Positive infinity. Okay? So for the interval notation, we're going to go from negative infinity to 3, union 3 to positive infinity. And I said it, but I don't know if you guys were paying attention. We're not doing the inequality part, just the interval part, okay? So this is going to be negative infinity to 3. It does not equal 3, so you keep a open parenthesis, union, start up again at the 3, and you go to positive infinity. So we have to split the domain at the 3 because of the asymptote. A darker color? Does that help? I'll do that for now. But and then the range is which values? The y values. So I'm going to switch color. I'm going to use pink for the range. So these are the y values. So now at my graph, I'm gonna highlight the y-axis this time, okay? So starting like at the bottom of the y-axis, I'm going to highlight until I stop at the 2. I'm gonna put an open circle at the 2, and then highlight at the top of 2. So I take my highlighter on the y-axis from the bottom, go until you stop at the asymptote, put an open circle, and then continue going upwards on the y-axis, okay? The asymptote says, again, you are not allowed to touch or cross that that value on the asymptote. So my range is going forever downwards to what? Negative infinity. And it goes forever upwards to what? Positive infinity. Okay? And it stops at what value? What's the asymptote value? 2. Okay? So for the range in interval notation, you go from the bottom to the top. Okay? So we're going to start at negative infinity. And you're going to continue to 2. You're going to put a parenthesis because it's an open circle. Union. It starts up again at 2, so put a parenthesis. And then it goes on forever to positive infinity. Okay? Alright, then it has like, is it increasing or decreasing circle 1? So if I look at the actual graph, going from left to right, so this is from left to right. I'm going to start here at the left side, go to the right. Which direction am I going? Downwards, right? And up here, same thing, from the left, going to the right, I'm going downwards. So it's always decreasing. Alright, so for today, we are going to be looking at radical equations, like the square roots and the cube root functions. But before we do that, we need to talk about end behavior. So for end behavior, we're going to put this somewhere, maybe I think even at the, let me look at your notes. So is there space for it somewhere? Maybe like at the bottom of that second graph. At the bottom left-hand corner, is it the left? I can left, yes. I had to think about it. So at the bottom of this corner right here, you're gonna jot down some notes for end behavior, okay? So end behavior, we're looking at the ends of the graph, okay? So for end behavior, you're just going to draw like an X and Y axis, just really super small. Doesn't have to be super big. So for my end behavior, going to the right forever goes to which infinity? Positive infinity, okay? And then going to the left is which infinity? Negative infinity. Going upwards is which infinity? Positive. And going down is negative infinity, okay? So we're going to use that for our end behavior. The left and the right are the x's because they're the x values. I'll say like this part, left and right, are the as x approaches. And the ones going up and down are like your g of x functions. Okay, so the left and the right, the end behavior is as x approaches. If it's the left side, you write negative infinity. As x approaches, if it's the right side, you write positive infinity. And then if you look at the up and the down, you would write g of x approaches. If it's going up, you write positive infinity. G of x approaches, if it's down, you write negative infinity. Okay? So I know right now it probably doesn't make any sense, but let's look at an example and then we'll come back. Sorry, does anybody still need that?
No.
We're good now?
Yep.
Okay. So for this example, it says find the key features using the graph of the radical function. So first you need to determine if it's a square root or a cube root. What I'd like you guys to notice is there's an endpoint there, right? So if there's an endpoint, that means there's restrictions on the x-axis and the y-axis. There's restrictions on the domain and the range. And so which function had the restricted domain? The square root or the cube roots? The square roots. So the restrictions, the restricted domains are for the square root functions. So because of that endpoint, that means your domain is restricted to certain values. So that means that these are the square root functions. So we're going to circle, this is a square root function.
Wait, how can you tell if it's a square root or a cube?
Again, the endpoint tells me that it's a square root because there's restrictions. It doesn't go on forever to both directions. The cube root functions, the cube root is going to look kind of like the S shape. It's going to have arrows on both sides. Because there's no restrictions, it'll have arrows on both ends. Well, it doesn't actually have the arrows, but there's no endpoint. So it signifies it's going forever. Okay? Like for example, this doesn't have an arrow, but there's no endpoint. So it's signifying it keeps going on forever. Okay? Alright, so what I'm going to do with my highlighters, again, I'm going to stick to blue for the domains. So whatever color you use for domain, kind of just stick to it so that you know that that's what you're using for the domain. The key thing here is you're going to basically kind of drag your curve to the x-axis, okay? So I'm going to take my endpoint and I'm going to drag it to the x-axis. And I'm going to put the endpoint right there. And then I have to figure out which side to shade, okay? So I'm going to drop my endpoint right here. And then I want to see, do I shade the left or the right side of my x-axis? If I cover this up right here, do I have anything on the left?
No.
Nope. But if I cover the left side, the curve is on the right side. That means I need to shade that way, okay? So I'm going to take my highlighter and I'm going to highlight this side because the function is on the right side. Then I'm looking for the value. So what value is this endpoint? What x value is that? Positive. Not infinity because it stops. What's that specific value right there? 4. That's a 4. And it goes on forever to the right side, which is positive infinity. Okay? And again, on your notes, you can cross out all the ones that say like set notation. We're not doing the set notation piece. We're only doing the interval notation. Okay, so for the domain, you want to go from left to right. So least to greatest. So I'm going to start at 4 because that's my farthest point to the left. It has a closed circle, so because of the closed circle, it has to have a bracket instead of a parenthesis, comma. It goes on forever to positive infinity. And the infinities, we never reach infinity, so we put it open parenthesis. Okay, for the range, I'm going to do the same thing, but now for the range, I'm looking at the y's. So I would switch colors for the y's. So you can switch highlighter. You're going to basically do the same thing, except now you're going to drag it to the y-axis instead of the x-axis, okay? So take your endpoint that's here. You're going to drag it to the y-axis. So I'm going to put that endpoint at the 5, and I'll put a closed circle. And then check, is the function below the graph or is it above the graph? Is it below or above? Is there anything below or is it above? Where's the curve? The curve is above, so I'm going to highlight the top part of the y-axis. So what value is this endpoint at right here again? That's a 5 this time. And that arrow is pointing up forever to what? Positive infinity. So for the range, you go from bottom to top. Okay, bottom to top. So the value at the bottom is 5. Bracket, because it's a closed circle, comma. It goes forever to positive infinity. We never reach infinity, so you put an open parenthesis. Okay, so for the end behavior, we're going to be looking at this that we did earlier. So for the end behavior, I got to figure out if it's the left side or the right side, or if it's going up or down, okay? So the end behavior, you're looking at the ends of the graph. So looking at this side is an arrow pointing this direction. So is that the left side or the right side of the graph?
Right.
This is the right side. And is it going upwards or is it curving downwards? It's curving upwards, okay? So this is a right up. So I'm going to be looking at the right up. So they're both going to be infinities, okay? But the first one is going to be as x approaches, and the second one is g of x approaches, okay? So we're going to say, for my end behavior, this is a right up. So we're going to say as x approaches, the right is a positive infinity. The function is g of x. It approaches upwards, and upwards is a positive infinity. Okay, then we're going to look at the other side. The other side, there is no arrow, is an endpoint. So because it's an endpoint, I don't need the other side of the end behavior, okay? It's an endpoint, so you do not use the end behavior for the endpoints, okay? All right. Does anybody still need that? There's the full thing. We're good? Okay. I don't see anybody still writing, so let's look at the next example. So for the next one, again, is this a square root or a cube root, and how can you tell? Go ahead and talk to your group really quick. Square root or cube root, how can you tell? All right, so what do we have? Square root or cube root? Square root because it's an end point. There's a restriction, okay? Good. All right, now let's look at the domain. The domain again is which values? X or Y's? X's, okay? So for my domain, I'm gonna drag the curve to the x-axis, okay? So take your end point and you're gonna drag it to the x-axis. You're gonna put an end point directly above or below, wherever it's at, go to the x-axis. And then check what side do you shade, the left or the right? Is the curve on the left side or is it on the right side?
The right side.
The right side. So you're gonna shade the right side and draw like an arrow because it's going forever to the right side. And then figure out what values those are. So this endpoint is which x value? -2. And it goes forever to the right to positive infinity. Okay? So when you write your range, you're going to go from left to right. So this is going to be a -2 with a bracket, comma. It goes forever to positive infinity. We never reach infinity, so we put an open parenthesis. Okay, and then for the range, we're going to do the same thing. So for the range, now you're going to highlight the y-axis because the range are the y values. So you're going to drag your endpoint to the y-axis. So that endpoint, you're going to go directly left or right to the y-axis. My y-axis is on the right side of that point. So there's my value. And the curve, is the curve going downwards or is the curve going upwards? Down. So we highlight downwards and you're going to put an arrow pointing downwards. And then check what values those are. So what is this y value on my endpoint? Positive or negative? Negative because it's below. And that arrow is pointing forever where? Negative infinity. Okay, and then this is where people tend to get confused because it's pointing downwards. So you're thinking start there, go down, but no. It's least to greatest. So you start at the bottom, go to the top. So the bottom value is what? Negative infinity, and it goes to the top, which is -1. Okay, so this is negative infinity to -1. There's a closed circle, so you put a bracket. Okay, so again, the range, you always go from bottom to top. Domain, you go from left to right. All right, for end behavior, we're going to look at the end of the graph. So the end of the graph is over here. So where is this pointing? To the left or the right? The right side. And is it pointing upwards or pointing downwards? Downwards. So this one's a right down. So a right down. We're going to start as x approaches. So we're going to say as x approaches, which infinity is the right side? Positive or negative? What is it? The right side? Positive. F of x, yes, is going down, so then you say g of x. There's two parts to it. So the right side always goes to positive infinity, and because it's going down, the down represents the negative infinity. Okay, so for your end behavior, the first part as x approaches, this is talking about like the left or the right side. And then the g of x piece of it tells you if it's up or down. Okay? So that means the right side goes down. And then the other one, again, is an endpoint. So because it's an endpoint, I don't need the other part of the end behavior. Did I talk about the increasing, decreasing on the last one?
No.
Oh, my man. Did I skip it? Okay. So from the left to the right, which direction is this going? So start at the end point and then go what did I just do? Yeah, because left to right, the previous one, the first one, from left to right is going upwards. So then this one's an increasing. The first example. The second example, from left to right, start at the left side, go to the right. Which direction is it going? It's downward, so it's decreasing. The set note?
Actually, you just did it. I'm so sorry.
Yes. I skipped it on the last one. I forgot about it. So the increasing, decreasing, you're looking at from left to right. What direction it's going? All right. I think the next one's a practice. So go ahead and try this one now. You guys are trying this one? Alright, so for this one, let's go over it. The solution, there was some confusion as I was walking around with the highlighting part of it. So remember, the domain is the x-axis. So you want to drag the endpoint to the x-axis. So the x-axis is on top, so you highlight here. And is the curve going to the right or to the left? To the right side. I think I'm doing my right and left, but it's, yeah. Anyways, so it's the right side, so you highlight the right side of it. And what value on the x-axis was that? -3, and it goes on forever to which infinity? Positive. That's why you get -3 to positive infinity. And then for the other one, the range, you look at the y-axis. So you're going to drag the point to the y-axis. And then is the curve going above or below that point?
Above.
It's going upwards, right? So you're going to shade above on the y-axis. And then look at the values. What value is this on the y-axis? -4. And it goes on forever to which infinity? Positive. Okay? So that's why it's -4 to positive infinity. And then for the end behavior, you're looking at this side. It's going forever this way. Which side is that? Left or right?
Right.
Right side going up or down? Up. So right up, that's positive infinity for both of them. Okay? And then from left to right, this is going upwards, so it's increasing. Okay? All right, let's go ahead and look at this next example. Just a second, let me just make a bathroom pass. All right, talk to your group. What do you guys think? Is this a square root or cube root? And how do you know? All right, so is this square root or cube root? Cube root, because there's no endpoints. Good. So this one's a cube root because there's no endpoints, and because there's no endpoints, there's no restrictions. Okay. So this is no endpoints. So there's no restrictions. And because there's no restrictions, this is a cube root function. Okay? So for the domain, my x values, it doesn't start or stop really anywhere. It continues forever. So you're going to highlight the whole x-axis this time. From left to right, there is no restrictions. Okay? So going to the left forever is which infinity? Negative infinity. And going to the right forever is positive. So remember again, for the domain and the range, you're going to go from left to right and bottom to top. So the left side goes from negative infinity, goes forever to the right side, which is positive infinity. And then for the range, I'm going to change colors. So my range are the y values. Again, there's no restrictions. It doesn't start or stop anywhere. It goes on forever in both directions. So you're going to highlight the whole y-axis. From bottom to top. It goes down forever to what? Negative infinity, and up forever to positive infinity. And the range we write from bottom to top. So the bottom value is negative infinity, and it goes forever to the top value, which is positive infinity. Okay, Now for the end behavior, this time I do have two pieces of the end behavior because I have arrows on both sides, okay? So it doesn't matter which one you do first, the left or the right, as long as you have the correct infinity with it, okay? So this one over here, pointing towards the top, what side is that? The right or the left side? Right side. And it's going forever up or down? It's going upwards. So for this one, it's gonna be right up. So when I write this, I'm gonna say as x approaches, which infinity is the right side? Positive. The function g of x approaches upwards. Up is which infinity? Positive infinity. Okay. All right, let's look at the other side now. The other side, I'm going to use green. So this time I'm looking at this side. This arrow, the end of it, is that the left or the right side? Left. And is the curve going upwards or is it going downward? Down. So that one's a left down. So for here, I need the left down. So as x approaches the left side is which infinity? Negative. The function g of x approaches downwards is which infinity? Negative. And then for the increasing, decreasing, I'm looking from left to right, okay? Increasing, decreasing, you look from left to right. Which way is it curving? So start at the left side, go to the right. What's happening? It's going upwards. So it's an increasing function. Okay? So I'll say for your domain and range for the cube roots is always going to be the same no matter what the curve looks like, because there's no restrictions, it's all real values. So the domain and the range is always going to be negative infinity to positive infinity for the cube roots, okay? So if I look at this next example, is this a square root or a cube root function? Cube root. There's no endpoint, so it's a cube root. Domain and range is going to be the same because there's no restrictions. The x-axis, I'm going to highlight the whole x-axis. And that's going to go from negative infinity to positive infinity. No restrictions. And we go from left to right. Okay. The range, again, no restrictions. So you highlight the whole y-axis in your other color. From bottom to top this time, it's negative infinity to positive infinity. Bottom to top is negative infinity to positive infinity. The domain and the range are always the same for the cube root functions. The only thing that's going to change is the end behavior and if it's increasing or decreasing. So let's look at the end behavior. Here, let's look at this side. Again, it doesn't matter which side you look at first, as long as you have like the right going the right direction and the left going in the right direction. Okay. So this one over here, is that the left or the right side? Right side, and it's going up or down? Down. So this is a right down. So the right down, we're going to start as x approaches, which infinity is the right side? Positive. Right side, so it's positive. The function, I was going to put f of x, is g of x is going downwards is which infinity? Negative. Okay, the other side, this side, is going in this direction. Is that the left or the right side? Left, and is going up or down? Up. So this one's a left up. So as x approaches the left side is which infinity? Negative. The function g of x approaches upwards is positive infinity. And then for the increasing, decreasing, we're going to go from left to right. So left to right is decreasing. Okay? All right. And then the rest of the notes is just practice. So I am basically done though. So for the rest of the period, it's 1:28, class is over at 1:35. So you have about 10 minutes to do the rest of the handouts. What is it, 4 examples or something? So that's what you're doing for the rest of the period. The homework, please don't start the homework. We're gonna do the homework in class tomorrow, so you don't have to do anything outside of class. Okay? So rest of the period, you're working on the rest of the notes.